So the first thing we'll do here is to translate these relationships algebraically. So let's say if these are the four numbers, the first condition is that the average of the first two numbers divided by 2 is 1 more than the first number. And then average of the first three numbers, so that would be their sum divided by 3, is 2 more than the average of the first two numbers. So yeah, I mean, it's kind of made up conditions, but they are kind of messy. Average of the first four numbers is 3 more than the average of the first three numbers. And they're asking for the difference between the largest and the smallest. So note we have 3 equations, 4 unknowns, but they're asking for this difference. So that will likely be a number. We may not be able to find the individual values, but this we would be able to. And this should also guide where we need to go. That means I'm going to try to end up with an equation which doesn't have x2 and x3, and I just end up with these two variables. So that will be my intention. So let me just start by simplifying this. And this is kind of how I did this question, because I wasn't able to see a easy way to add or subtract these equations and eliminate and end up with this relationship. Perhaps there is a way, but at the moment I don't know. So this becomes x2 is 2 plus x1. That's my first relationship. I want to simplify this 2 by multiplying both sides by 6 so that I get rid of these denominators. This is a 2, so don't make these kind of mistakes. So that becomes, and this is where when you're doing it in the exam, you do have to kind of skip certain steps, and that's kind of what I'm doing, and I hope you can keep up with me. So this would be 3x1 plus 3x2. Again, that goes out, this goes out, so now I end up with 2x3 is x1 plus x2 plus 12. So that's my second equation. That's first. Then I'll do the same thing here, multiply both sides by 12, and I'll get, so yeah, it's still quite a bit of work in terms of doing this manipulation and then cleaning it up. So 4x1, 4x2 plus 4x3. Then these disappear, and then that becomes just x1, x2, x3. So 3x4 is 36 plus x1 plus x2 plus x3. So now I have to see, how do I get rid of, so first thing I will do is to get rid of x3. So I'm going to substitute that here. 3x4 is 36 plus x1 plus x2 plus x3 would be half of that, half of x1 plus x2 plus 6. And now an equation with x4, x1, and x2. Since my goal is to get something with x4 and x1 alone, I'll replace x2 with x1. So this will be 36 plus x1, and then x2 is 2 plus x1 plus half of x1 plus 2 plus x1. Yeah, it's easy to kind of get confused. So this whole piece is equal to 3x4. So let's see if I can keep this manageable. 36 plus 6, that's 42 plus 2 plus 2x1 plus half of 2x1 plus 2. And then that's going to become x1 plus 1. So that becomes 3x1. So 3x4 is 3x1, 42 to 44 plus 145. Divide both sides by 3. And now we get the difference, which is what I needed for the question. And that's answer 15. So yes, I mean, this can be stressful to do under exam, under time conditions. But you have to make a decision early on. Is do I clean up the equations and then just try to substitute, or perhaps look for a pattern up front, which is usually what I do, but I didn't see anything here. It's possible that I'm missing it. And so I just had to do this kind of brute force, where the approach was to get rid of these two variables because the question is about this difference. So that was kind of the guiding principle. So to summarize, the answer is 15.